Hello and welcome. Today we are going to study System Verilog interface. This concept is one of the most important and widely used concept in System Verilog. As we know, to testify or verify a design, we have to create a top bench or a test bench module so that we can declare or initiate different types of input signals, therefore to testify the design. For that, we have to connect signals or port which has been declared in test bench to the design. In the traditional way, we have only a two ways. That is, one is positional mapping and another one is name mapping. In both of case, we have to declare each signals for test bench and for design to connect them. It was a simple method for the design which have a minimal or smaller amount of signals. But the complexity arises when we deal with the complex design or this design which have a large number of signals. To deal with that complexity, the interface concept is arised, which is like that. Interface is a bundle of signals which which is declared as a module, which is declared as a separate module, so that we can use it in a different modules or a component for throughout the test bench or design. In the simple word, interface is a way to encapsulate the signals into a block. Similarly, like here we can see that this is a design which is under test and stimulus. Just like that, we have created different modules to initiate or give the different types of randomizing the input for different outputs to verify the different outputs. Here we create a block, that is interface, in which we declare our original signals which we have to randomize or get the value from the design to verify it. Okay, so basically we are creating a block which is which hold or contain the number of all the signals which is declared in a design and which connect the design and the stimulus in between the test bench. Okay, so for this we can understand that what is interface. So the let's make a point. Interface, it is a way to encapsulate the signals into a block. Okay, in a simple way we can define it like all the signals are grouped together to form a bundle or interface. Okay, so this is a basic understanding or concept of interface. Moving on, the syntax, how we declare a interface. So first of all, it's just like a module. Declare it like a module, not a module, but as we declare a module, in the similar way we will declare an interface. How? Let's see that. First, write interface. Okay, name of the interface, parenthesis, and here port list. Port list means the the ports which we will initiate or declared in the test bench. Okay, and similarly as we end the module, like which end module, here also we will close the module or like interface with end interface. Okay, so this is a simple syntax, and in between that we have our signals which we have to connect between the design and stimulus in between the test bench. So this is a simple syntax similar to the module. I guess you got this. Okay. So let's take a simple example to understand how we can implement interface in replacing the traditional way of connecting or mapping the signals between the test bench and design. So here we take a simple example of counter. As you know, counter is like it's when we initiate it, it's count from one on one, from zero to like the digits or number we declared. Okay. So here this is a design, we can see that. Okay, and this is a test bench to testify it. So this is a very simple example. Here we are declared the ports, which is a clock, reset, enable. This is a sequential circuit, so we use clock to deal with that. Okay, firstly an internal signals like count, and we have some conditions at which situation or conditions the counter will proceed. Okay, and this is a simple test bench to generate the inputs and get the output. Okay, so here we can see that the one of the traditional way, here we initialize the module, which is this design module, and connected the ports, here the signals, as a positional mapping. Okay, like dot clock parenthesis clock, which means this clock, this one is a test bench signal, which is this, and this one is a design signal. Okay, so this is a traditional way to connect the design and test bench, their signals. Okay, so here we can see that there are a smaller number of signals, like there is only three, so this is like very simple and easy to use. But when we have a lot of numbers of signals, and this arises a complexity between every design have a multiple test modules in which different team work on different modules, so they have to they will not declare every time that each signal every time, so we use the concept of interface over there. So to basic understanding, we will just let implement this on a very small and a simple design. Okay, we have over here syntax, so let's implement it. Okay, so what's this like code for interface for this counter example? So first declare the name, let's like count underscore interface, this what's, give any name, and here the port list. Here we can see that we have initialize or declare or give the input in the test bench clock, reset, and enable. We are giving the inputs to the design module and getting an output of count or as an internal signal. So for port list, I'll only write as we have input clock, so which will get the test bench, and another signal we will write over here. So here I am writing like logic. In system Verilog, we usually write data type as a logic, because logic can be used in assignment or a procedural block. As in Verilog, we have used like a wire and reg, which have a constraint of using in any of the block, not both of them, and they have only two values, 0 and 1, as we can given as an input. So logic can be used, is used mostly like that, it can be used in both procedural block and assignment block. Okay, and we can have a 4 state value of the logic. So basically in general we always use logic in dealing with interface. Okay, so this is a basic simple structure, simple syntax for interface using over here. So we will we don't have to make any changes in design. We have to only make the changes in test. Okay, so first of all, here we have a clock reset and enable. We have to declare or initiated them as a data type as a bit, as because we are only dealing with the one value. So let's now initiate a handle or create an handle for the interface. Create an object handle. How we will create it? Let's see. Similarly to the how we initialize the design module in the test bench. So first of all, write the name of the interface which we have given like counter underscore interface. Give it a name like INTF. Okay, and declare a port in between the parentheses. Okay, done. This is very simple, like declaring an interface in the test bench. Okay, now we have, like in the interface, we take the input clock from the test bench and connecting the reset and enable signal between the test bench and counter. So here, every time we use the clock reset enable, we will use the signals of interface. How? Let's see. Here, this is signal of the test bench. Okay, and this is the signal of design. But see here, as we declare the variables over here test bench as this bit, okay, clock reset and enable. To connect with the design, it goes first to the interface and then to the design. Okay, so basically what we are doing, we are only doing in the test bench, we are doing like connecting the signals of test bench which we are declared and connected with the signals which declared under the interface. Okay, so here we have created the handle. So what are the signals over here? See, intf dot clock. Okay, it's the way to initiate or declare the signals which we have initiated in the interface model. Okay, and intf to enable. Similarly, at every place you can write like dot clock. Basically we don't have to write over here as it's so. Here it's necessary because we are uh, like transmitting or transferring the clock signals from test bench to the interface, and then interface is transmitting that signal to the DUT. Here the clock itself is declaring over here only, okay, in the test bench. So this is the signal clock which is declared here as it. Okay, so don't need to write the clock as a intf dot clock. Okay, it's only a clock. Now we are initializing the signals like clock. First it's a 0. Okay, now as reset and enable signals are declaring or initiating between in between the under the interface, so we are using that intf.rst and intf.enable. So here we are declaring the initiating the signals after 10 nanosecond. Similarly, declaring the reset signal as this intf.rst equal to 1, and after 5 nanosecond intf.enable equal to 1, and after 100 nanosecond the simulation will be completed, and this is like we are generating a waveform. Okay, so this is the basic like syntax or basic example to implement the interface. Okay, let's check it and how it works. So I'm using a EDL playground, which will be like most commonly used for which can be used for like your most common tasks or daily practicing. It will be it's a very good platform to practice over your skills. Okay, so here I already like written the code of simple counter which uses the traditional way of mapping the signals or connecting the signals. Okay, so let me first run this so you can get a basic understanding of how it is, how it goes. See, we have a waveform. Here we are generating the clock, okay, the enable signals and reset and the internal signal of count. Okay, so initially we have a count like 0. Okay, as a clock generated, this is a positive edge, this is a negative edge. Huh. At the 10 nanosecond we initiated the like sorry here at 0 the reset is 0, and at 10 nanosecond the reset value will be 1. So similarly this, and after 5 nanosecond the enables, as the enable signals goes high, the counter starts counting like from 0 to 1, 1 to 0, from 0 to 1, 1 to 2, and so on. Okay, so this is the basic like counter example. Now we will implement this using interface. So let me like I already wrote the code, so paste it over here. I have module test bench. Okay, see. Now we will declare as a separate file from for interface like interface.sv. Okay, the file has been created. So what will be the content? Here, the interface which we have wrote over here. Paste it and save. Okay, so we have an interface which will connect the design module and the test bench. Oh, let's always remember to include the file which you will declare or create. Okay, sv. Got it? So we have written this. Now just let's see what will be the output. So see, we are getting the same waveform as we get from the traditional way of interconnecting or mapping the signals. So this is the concept of interface which will be like very useful and widely used in the most of the projects and designs and to testify or verify the designs. Okay, so from over here I'll like mention some points for the interface like as we see we are only declare the inputs or signals ports which we are dealing with in design. Okay, so in the interface there are a lot of advantages and lot of usefulness of the interface, which may be like we can declare a directional information for the interface using that mode port. It's a data type which will be used to like indicate the signals are going from design to interface, sorry, test bench, or from test bench to design. Okay, and the interface, and we can also declare or define like a timing information using the clocking block which will be used to generate or like and just understand like sampling the signals, input and output signals, like over the positive edge, before the positive edge, or after the positive edge of the clock. Okay, so the clocking block is used to sampling the signals before commencing of positive edge, that inputs are prepared before the positive edge has arrived. Okay, so these are the like information which can be declared or defined in the interface. And also we interface can have constant variables like and parameters, function, task, many of the things. Like interface also can have a module inside it. So interface has a many of the useful function which will be like you will see in the further concepts in dealing with like creating a system Verilog verification and different test environment for the designs. I'd like to mention some of the advantage of like test interface over the traditional connections like mapping. First of all, like it's like a interface can is like allowed number of signals to be grouped together, as I already mentioned. Secondly, the interface declaration is made once. Like here we only made an interface signal declaration like as a file, and which can we can use in different type of modules. Like here we have a test bench module. We create an handle of interface and use the signals over here. Again, we can as similar we can use it in the different modules. Like, and if we will study like in the test environment, we have a different type of modules, driver, monitor, scoreboard, which will use the signals. So the major advantage is the interface is declared only once, and the handle is passed across many of the modules and components to use over there. Okay, and addition or deletion of signals are easy as because we are only declaring it at once, so it will be a lot more easier to add a signal or delete a signal. So this is all about interface concept. We have gone through the basic implementation of interface to connect the signals between design and test bench. Hope you understand the concept, and thanks for watching the video. Have a great time ahead. Thank you.